All you have to do is dig into it and you'll see it falls apart. Not only that, the main reason it falls apart is actually because it's the theory itself is conceptually incoherent. And if you have a conceptually incoherent theory, it can't make predictions and it can't be supported by any evidence. So that's the strongest argument I have. But then there's also individual experiments. I go into them a little bit in the book. But I have, let's say, different interpretations from how they've been normally presented. So there's the Hefeli-Keating experiment. There's muons. There's lots of things we could talk about. GPS satellites. I say those are not evidence of time dilation.
Okay.
For example, muons, I think, based on what we know about the muons, I think they actually move faster than the speed of light.
Mm.
And so, but we always just assume that's not possible. So if that's not possible, then it looks like the muons must be slowing down the rate of decay. I think it's more likely that they're just moving faster than the speed of light, which would prove. So first of all, we don't have time dilation like we thought we did, but not only that, we have faster than light travel, which is supposed to be
Yeah.
impossible. So then that same evidence actually disproves relativity in two different ways. With the satellites, I go into the twin paradox because the same problems we have with the twin paradox, we also have with the GPS satellites.
Yeah.
It might look like they're slowing down from our perspective here on Earth, but what about the perspective on the satellites? That's what we have to think about too. We can't
It's
just
the same.
use one perspective. We have to look at the whole elephant.
Because the special relativity is saying there's no absolute frame of reference, no? So if you don't have, you can take both, you can choose both ways. Any twin can be younger, and it's the same thing. And this is impossible.
Yeah. Yeah, it doesn't make sense. It's kind of like the many worlds hypothesis, right?
Exactly.
Every observer gets their
It's
own world
impossible.
where it can make sense, but and then we can ignore the conflict. But actually, I think we should deal with it because I actually think there's only one reality. Uh, unless simulation theory is true, there is only one reality. If this is all just a simulation, then okay, we can all have our own place in the matrix. But I believe until it's disproven, I'll continue to believe in a single reality.
Normal.
Yeah, that's what we've believed for hundreds of years, right? But
Yeah. But it's the only choice. You cannot believe in two worlds because we are making the same, we are living in the same reality. It's not possible to live in two realities. And then to meet, then to split again, meet again, and so on. I don't understand this. How can you live in two different realities, two twins, and then meet and have the same result, and then split again and have different results in different realities? There
it's
is no
almost like
point.
a Monty Python sketch of an argument, really. Yeah, it's absurd. So,
Yeah.
but that's what happens when you're backed into a corner and you don't know how to respond to a question. You just say, well, you get desperate and you come up with a really far fetched idea, and then somehow it sticks. I don't know how, but quantum. No, to be fair, quantum mechanics. The our observations of light are very hard to understand. It's very hard to understand how light could have a constant velocity relative to all observers. I finally figured out how it could, right? But in order to do that, I had to use another really weird idea, namely superposition. How can something be doing multiple things at the same time, right? How can something be in multiple
Yeah,
states at the same time?
but this superposition from quantum physics, I think it's also wrong because
Mm-hmm.
it's not for me. These probabilities are or superpositions are not the real thing.
Mm-hmm.
It's the same reality. It's not a probability. It's something which is traveling with speeds bigger than the speed of light, and it's not possible for us to observe these speeds. So it's
Yeah,
like being in different position for us because we are observing just some different moments of the travel, not a continuous travel
yeah,
traveling.
we're making up a story about what we can't see, and
Yeah,
there's problems with the story, and also the concepts we're using, we're kind of extending them. So, like, this idea of electron spin. Well, is it really spinning, or maybe it's doing something else? We don't know, right? Is that some
yeah,
people say, well, that's not literally spin. There's not nothing. It's a point. It's not actually spinning, right? Uh, a lot of the times when we're dealing with these very small, very extreme conditions, we're extending our concepts, and sometimes we don't really know what we're talking about because we're not dealing with the ordinary concepts we're used to.
yeah.
Uh, it's like this is a new situation. What are the rules that apply to it? Oh, I don't know. Let's try this, see what happens. Let's try that. So we're using these words like particle. Particle probably doesn't apply to a lot of these um, quantum mechanical entities. Wave also doesn't really apply that well. But I came up with an idea called superwave, which I think does apply.
Yeah,
Right. So I
so
think light is a superwave.
yeah, so it's traveling always with maybe instantaneous or something like this with very, very big speeds, much bigger than speed of light. But we can observe just this speed of light always.
Mm-hmm.
So this is
Yep.
making special relativity to be true. But it's true for us. It's not really happening. It's not the real thing. It's just
Mm-hmm.
real for us because we this is what we can observe.
Yeah, that's one thing I think people like about my theory, and I like it too, is just the idea that it's suggesting that there's way more light that we can't see, that we didn't even know about. Although it's not totally true because energy is still conserved, right? So there's still the same number of photons and all that stuff.
Mm,
But the potentials that exist are way bigger than what we are currently aware of, right? The idea that that we only see this tiny bit of the light in a new way that we never thought about, right? We kind of
mm.
know, yeah, we don't see all the wavelengths. You can't see light if it doesn't hit your pupil, etc. But it's not just that. If it's going the wrong speed, you won't see it, but it's still there.
Mm. So you said in this podcast you made, I saw,
Mm-hmm.
if I have a spaceship and I'm traveling and I reach the speed of light, step by step, but not so I'm accelerating
Yeah.
and in a specific moment I reach the speed of light.
Mm-hmm.
What is happening with a guy which is observing the light which is coming from my spaceship, or I observe the light which is coming from Earth. So
Mm-hmm.
if I reach the speed of light, you said, because I'm using light to observe Earth or the spaceship from Earth, then the time is frozen because I'm using this light. And light, if I exceed the speed of
Mm-hmm.
light or reach it, the light, it's not coming anymore. It's not reaching Earth from the spaceship or spaceship from
Mm-hmm.
Earth. It's frozen image. It's a frozen image. The last image I uh, obtained, and this is so-called time dilation. This is so-called time stops,
Yeah.
but it's not real. It's just
Right. Well, that's so. Uh, the guy I was talking to, Arif Ali,
yeah.
he was talking about Einstein's original, like early thought about time dilation, but
Oh,
that's not really what the theory became later.
mm,
It became, it is still something that's somehow both subjective and objective in a weird way, though, because the two twins in the twin paradox, both of their realities, until they come back together to meet, both their realities are equally real, even though they're
yeah,
contradictory,
yeah,
right? Uh, it's really true that this twin aged more than the other, and it's really true that it's the other way around also. But because there's no way for them to verify this, they can each have their incompatible realities.
yeah.
Uh,
Two incompatible realities.
so I also went through the difference, right? So there's two types of time dilation. There's what I call inertial time dilation, which can be called many things, relativistic, kinematic, or whatever. But it just means, it's time dilation from motion that's in a straight line, right? Constant speed. Uh, and then there's gravitational time dilation. The big difference between these two is that the inertial time dilation is purely subjective. But,
Yeah.
and the reason being, the twins in the twin paradox both disagree. Who got younger, right? Who got older? They can't agree on that. But with gravitational time dilation, both twins or both people would actually agree. Okay, yeah, I definitely got older. You definitely got younger. So it's objective. That's the big difference between the two.
Mm. Yeah, but I think in an objective way it's not happening.
Yeah, I think
So,
I think that we can rule out the inertial time dilation as wrong because it's subjective. It can't be right. It can't be objectively real. But with gravitational time dilation, it's a bit different because I think it is objectively true, but it depends on the clock you use. I think that it only affects atomic clocks or maybe
mm,
quantum objects. So quantum objects respond a certain way. I think it's a quantum effect,
mm,
but it doesn't happen to macro objects. So, I mean, we can't say either way at this point because it's not been tested. But it doesn't happen to say a grandfather clock.
mm,
Right? There's no gravitational time dilation for a grandfather clock, although there is, but it's actually the opposite direction from what's predicted by general relativity. So the gravity actually, less gravity results in a slower clock in reality when we're talking about big macro objects. But we're talking about tiny atoms. For some reason, with the atomic clocks, less gravity means faster.
mhm.
So
Okay.
it's complicated. It's complicated. Very hard. That's why most people don't get into this stuff. Most people are not that interested in it. But uh, even the thing is, I haven't had a lot of chance to talk to, say, tenured physicists, professors, because well, I don't know why. Probably for a lot of reasons. But for one thing, I'm not a physicist. I'm not a physics professor
Oh,
myself. So they're less interested in this. They each have their own narrow specialization that they're interested in, and
oh, yeah.
they're probably not interested in questioning the fundamentals that we've been relying on for hundreds of years or more than 100 years, right? But um, you know,
So
to them,
now,
I'm just some random person, some
yeah,
random schizophrenic on the subway,
yeah.
telling them they're wrong.
But now, do you have some feedback from the scientific community?
None at all. I just get complete silence.
Complete.
Uh,
Oh,
Complete silence. No criticisms.
yeah,
No
and
nothing.
it's
No
wrong.
positive. No
It
negative.
should
Nothing.
be somebody who you saw. It's it happened 2 weeks ago, I think. Some guys
Mm.
wrote a paper which is unifying fields.
Mm.
Some equation about the Planck. They talked about Planck at the Planck scale. Time and space are entangled and sweeping.
I didn't read it, but I haven't heard anyone refer to my ideas yet. So,
Uh,
but uh, either
and
negatively or
and
positively.
immediately after they wrote a paper in a few days,
Okay.
guys on YouTube
Hmm.
immediately made some videos which are proving they were wrong.
Are you talking about
Mathematically,
dialect?
they missed the equation, they missed
Hmm. I'm
things
not
of
up
that.
on it. I
Yes.
haven't heard about it, so I'd have to get a briefing or maybe watch the YouTube video. But I know about dialect. So there's the guys who
Mm,
interviewed me in Nepal. They're challenging Einstein in their own way,
mm,
and I know dialect has come up with a number of really good videos.
mm,
I don't agree with dialect on everything. I mean, he accepts a lot more of
yeah,
Einstein's ideas than I
yeah,
do,
yeah.
but we agree on a lot.
Maybe
We're
they are
basically in
on
the
the
same
same
corner.
path, but not in the same step.
They believe in time dilation.
Mm,
They're just trying to explain it differently from how I do. but they accept it. They also believe in ether. They're starting to really undermine Einstein's definition of time, just as I have. I don't think time is just what a clock measures, right? I think it's a basic dimension, a part of reality, and I think it has to be objectively real. I don't think
Yeah.
that, I believe there's a such thing as a broken clock, right? Clocks are not always right, and some clocks are more right than others. And if two clocks disagree, one of them has to be right and the other has to be wrong. Or maybe both of them are wrong, but I wouldn't say both of them are right. I might say both are wrong, but not both are right. And same with the twins. Both twins can be wrong, but both can't be right.
Mm.
And quantum mechanics and relativity can both be wrong, but they can't both be right. And we already know that because every time we try to unite them, we come up with a disaster theory like string theory.
Yeah. So the consequences of your theory, if I experimentally, if I am in a spaceship, what is happening?
So,
And reach the speed of light, exceeding the speed of light.
yeah. Well, you can make a spaceship that, there's a lot of engineering challenges that will come up. But if we ignore all of that, let's say you have thrusters that you have infinite energy on board, and you have thrusters that can push you to accelerate any direction you want at 9.8 meters per second squared. So you'll feel like you're back on Earth with gravity, right? But you can just accelerate in any direction. If you do that, I say you would continue to accelerate at that speed forever, unless something stops you.
Yeah.
Things will, because there's all kinds of dust and particles and gas and objects in space that will probably stop you. But if we clear all the obstacles out of the way, you can just accelerate forever. Nothing will stop you. The laws of physics won't stop you. And so that means after 1 year of accelerating, you're already going faster than the speed of light. And, after 10 years, you're going 10 times as fast. And so I think that you can actually do that.
But no, this is not creating a war bubble or nothing. No relativistic effects, nothing. It's just exactly like on Earth, driving with car. It's just the normal way. But I think when you exceed the speed of light, you'll become invisible for Earth. And Earth for you.
I don't think so.
No, but how to detect, how to detect these things which are behind you and you are exceeding the speed of light? How to obtain the information from behind?
Okay. In theory, I could be accelerating, just as I mentioned before, I could be accelerating away from you and twice the speed of light, and I could shine a flashlight back at you, and you'll still see it. So, for example, let's say I'm moving, I'm 1 light year away from you, and I'm moving at twice the speed of light, hypothetically, okay? And I flash a light back at you. What's going to happen is exactly 1 year later, you'll see the light, but it will be very redshifted.
Okay, so this means the light will travel. It's a superposition in velocity space, and will travel with a speed bigger than the speed of light. But I'll observe this light. Doesn't matter after.
So here's how it works. Okay.
But I will observe it as a beam which is traveling with the speed of light. Nothing, no more.
Yes. So the light you saw moved from me to you at the speed of light. But that same beam that you saw is not what I see. So I could never see that light. But relative to me, it actually moved faster than the speed of light. It moved at 3 times the speed of light. So I don't see that light. So it's like it doesn't exist to me. But to you, it does exist, and you see it. And because I was 1 light year away from you when I shined that at you, it takes 1 year to reach you. It's that simple.
Okay.
The beam doesn't care how fast I'm moving when I shoot it. It's got nothing to do with me. The speed of the source has no effect on the speed of the light. So, and that's according to the second postulate. I'm really just being consistent with the second postulate. Very few people are consistent in applying the second postulate or the first postulate to their theory. So I still say there's no absolute frame of reference. A frame is just a point in velocity space, and all points in velocity space are essentially equal, and all that a speed is the distance between them, and then the direction is the direction.
Okay, so I'll continue to see the spaceship from Earth, but
Mhm.
after a while, not exactly. Yeah, this is normal because it's always happening to see the light after a while, not instantaneous.
Think about it with sound. If I was moving, like you're stationary and there's no wind, okay?
Mm,
I'm moving away from you and I'm yelling at the top of my lungs. You
mm,
could still hear me. Even if I went faster than the speed of sound, you could still
mm,
hear me. It would just that I would get quiet very fast and my voice would sound very, very deep.
mm,
So it's the same thing with the light. You would still see the light, but it would be very, very red shifted. And
mm.
it would get dim very quickly because I'm moving away from you so fast.
Interesting. So these airplanes which are traveling with speed bigger than the speed of sound, you can hear them.
You can still hear it, yeah. If a motorboat goes by you at faster than the speed of waves, of the water waves,
Mm,
it creates this huge wake, but you can still feel the waves coming from the motorboat. It just
mm.
takes a while for them to get to you.
Yeah, interesting. I didn't thought
Because,
about this this thing.
but it
Yeah.
is weird though, because like we're dealing with the medium that light travels through, so uh, there's all these contradictions that come up when it comes to multiple observers. But from your perspective, from like if we're just talking about what you will see, it makes sense to imagine that you are stationary in the medium. So if you want to imagine what you will actually experience, just imagine that light's traveling through a medium and you're stationary in the medium. So with sound, that would be like if there's no wind, I'm moving relative I'm moving relative to the air, but you're not. What can you hear? Or if we're talking about water, you're stationary in the water, the waves are moving relative to the water, and some fast motorboat goes by you.
Mm,
Its waves will still reach you.
yeah.
Why wouldn't they?
Yeah,
Because the boat doesn't pull its waves with it, right? That's the trick.
And
Nothing's
the speed of waves will be the speed of the boat? No.
right. Exactly. The speed of the boat has nothing to do with the speed of its waves.
Okay. So
Yeah, it's
if something is exceeding the speed of light, it is still visible, but
well. Don't forget, there's no such thing as what speed anything's moving at, right? Like it's the simplest thing, but yet it's easiest to forget, right? There's no such thing. What speed am I moving at? There's no such thing. Can
mm,
I exceed the speed of light? No, because I'm not moving at any speed. There's no such thing as what speed I'm moving at. That's why. So no matter how fast I accelerate and what direction I accelerate, there's still no such thing as what speed I'm moving at. You always have to specify what's the reference frame relative to what
exactly.
relative, and so that's why it's actually meaningless to say, oh, in a spaceship moving at the speed of light. No, 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 no. We've already made a mistake. Erase everything and start again. In a spaceship moving relative to Earth at the speed of light. Okay,
Exactly.
okay, now we're gonna okay.
But what is the speed of Earth?
Relative to what?
Yeah, relative to
But
I
that's
don't
that's
know.
why that's the problem that I started out
Yeah.
with. That's why I came up with velocity space. Because now I can say, okay, I can't say what the speed of Earth is, but I can say it's a point in velocity space.
Mm,
And then I can say I'm here. And then if you want to ask, well, what about the speed of the Earth? Well, it's also moving relative to me, but it's moving relative to something else and something else and something
mm,
else. And you can just keep putting things here. And you can use Pythagorean theorem, and you can there. It's
mm.
like a matrix or like a web of
Yeah.
relationships between objects, which exists no matter what frame we put on it. Those relationships are real no matter what grid lines we decide to create. So we don't actually
Yeah, we
need the
don't have
grid.
an absolute speed or an absolute frame of reference in the
Yeah.
universe.
Everything
Everything
about
is relative.
Everything
It's
about
not
special and general relativity is based on the grid. It's all about creating a coordinate system and using that. I say we don't need a coordinate system. These objects still have real properties independently of what coordinates we impose on them. And I talk about a velocity space grid. There's a grid of velocity space which we can impose on things, but it's not real because the zero in velocity space can go wherever we want it to go,
yes,
right?
it's relative.
But
It's not absolute.
but the relationships between the objects in velocity
The
space, those
origin
are
is
real.
everywhere.
Yeah,
It's
they
subjective.
exist before us and they will exist after us, and
Mm.
we can make all the arbitrary decisions we want. It has no effect on the reality.
Huh. Uh-huh.
But nobody does
Yeah.
this. I'm the only one. Honestly, in all of physics, nobody is using velocity space in this context. It's used for like the molecules in a plasma or whatever. It's used for some limited context, but it's not applied to special or general relativity, which is where we really need the concept of velocity space. And I think there's no accident because it clarifies everything and it creates an instantaneous conflict with special relativity once you begin to think about velocity space and actually apply it.
Yeah. Okay.
Velocity space is not compatible with special or general relativity.
Okay. I must think about this, what you said now.
Mm-hmm.
These things, with this experiment with this, with the spaceship which is exceeding the speed of light and it's still visible on Earth. This
Mm-hmm.
is a thing I didn't thought about this at all. This is the first time I realize
Well, guess what?
it's true.
We already can see objects that are moving away from us at 10 times the speed of light.
Yes.
Those are very distant galaxies.
Yeah.
We already know, based on the fact that they get, theoretically, if we're interpreting the redshift correctly, they're
Yeah.
getting further away from us by at least 10 light years every year. So
Yeah.
they're moving, but we've sort of attempted to redefine motion to make them not moving. So they'll say the space is moving relative to space, but the galaxies are not moving relative to space, which
What
is,
is this
it's
space?
just bafflegab. It's just bafflegab.
The
It doesn't
space
mean
is the same
anything.
thing.
It's an attempt to get away from the conclusion that we're witnessing superluminal motion when we
Yeah.
look at distant galaxies.
Already. Yeah.
That's the most straightforward explanation. There's this convoluted way to escape that by saying, well,
Yeah. You're blaming
there's
space,
a
but what is
preferred,
this space?
there's somehow a preferred frame for each galaxy, and these preferred frames are moving apart, and it's not really the
And
galaxy. Oh, give me a break.
in the first place, for Einstein, the space it's not ether is not something. It's not a physical thing. It's just a mathematical distance between objects. How can this
Hmm.
be? This mathematical distance in calculations can exceed the speed of light. How can this be? And without implying the movement of the galaxies with speeds bigger than c. It's
Yep. If
mathematical
look,
concept. The space is just
it's
a mathematical concept for
hmm,
Einstein. So this cannot be something which is pushing galaxies. It's just a measurable
right.
distance and nothing more.
You're
It's a
you're
concept.
absolutely right. You're absolutely right.
It's not
It's
physics.
something. This is something that happens a lot. Is there's this epistemological claim and then there's an ontological claim, and they're always
Uh,
getting mixed up together, right?
so
Are we
if
talking about
it
something
is,
that's epistemological, or are we talking
yeah,
about something that's ontological? Is this
yeah.
just a reference frame, or is it a real thing? These
It
are,
is something which is material which is exceeding the speed of light. If this is happening, it's material. It's not just a concept. It's not just a
mhm,
measurement. Just
mhm.
measurement. It's something which it's pushing galaxies with speeds bigger than c. So it's happening in a material way, and
If
this is
if
proving, yeah,
if the space that this galaxy's in can move
mm,
away from the space that another galaxy is in, a
yeah,
distant galaxy, then the space has a what I would call a location in velocity space. So there is a preferred frame of reference, right?
it's absolute, yeah,
If we say that, then we're throwing out all of
exactly.
relativity because
All
all
the
of
relative,
relativity
it's wrong.
is yeah, exactly. So
And this
they
space is not moving, and it's stationary, absolutely stationary, and it's destroying the first principle. No,
yeah, so we have to make up our mind. Either relativity is true or false. Either there is an
yes,
absolute
yeah,
frame or there isn't. We have to make
yeah.
up our mind. We can't just leave this hanging and have it both ways. Uh, I decided, well, I'm going to go with there is no absolute frame of reference and see how far I can take that.
So
And that's
the
what I've
space
done.
is nothing. It's not.
But you know what? You could just as easily say maybe there is an absolute frame of reference. And that's what the guy who interviewed me has done. He's decided
Mm,
that there is an
mm.
absolute frame. And
Can be,
that's
but
sort
we cannot detect it. How can we detect it in this
well,
universe?
their idea is that it looks like there's a lot of different sources of evidence to suggest that Earth is special. So
Mm,
now, if you're looking at it in terms of gravity and the way the planets move, yeah, it's pretty clear that the sun is the center of our solar system, right? And yes, Earth rotates, right? They agree on that, but their idea is uh, that light moves at a certain speed relative to Earth,
mm,
which wouldn't apply to say Mars or some other galaxy or whatever, right? That's their idea.
yeah.
Uh,
But
and
maybe
you know what?
The Big Bang location in the
The,
space-time, it's exactly that absolute frame of reference. Maybe
mhm.
that point, but that point is lost in history. It's not. We cannot see where it was. The exact point.
What do you mean?
I want to say there is if there existing this absolute frame of reference,
Mhm.
maybe for me it should be the point of Big Bang, from where all the universe exploded.
Oh, okay.
Specific location in space time. But how can
Mhm.
we see where is that specific location?
So that would be the center. Just find the center. There
Yeah,
could be a center. Uh, we have no idea because we don't know how big the universe is. We don't know how much of it we can
yeah.
see.
And from
There's
where
so
it's
many things
coming.
we don't know. Uh, it's all very, very speculative. Personally, I don't even really believe in the Big Bang.
Yeah,
It could have happened, but I don't. I just think that there's lots of other possibilities that I'm entertaining,
yeah.
and
It
the
goes like
more evidence we collect, the less and less I believe in the Big Bang. So
yeah.
yeah, where was I going though? But yeah, is there anything else that you want me to help you with straightening out the details of my theory or?
Um, I don't know. Something
Hmm?
mathematical
Hmm.
in this velocity space, which is proving relativity wrong.
Oh, so well, I have to look for evidence. So one of the ways I can test this theory is my theory makes a novel prediction,
Mm,
supervelocity and selection theory. It's sort of related to what we were just talking about. Like if I was going away from you really fast and I had a flashlight, it would still take 1 light
mm,
year for that light to get to you.
mm,
Uh, but the thing is, if you change your speed, like if you're accelerating away, it would get to you faster. And if you were accelerating towards me, the light would get to you. It would take longer.
mm,
The reason is the light you see is still going at a c relative to you, but relative to the source of the light, it's changed its speed, right? Not the light's changed its speed, but the light you see has changed its speed
yeah, it's
because you're
changed.
seeing different light. So I use that relationship to make predictions about what we should observe from distant pulsars or other pulsing, you know, things that are ticking, you could say,
Yeah.
in space based on what time of year it is, because Earth is moving in velocity space. We're changing our speed and our direction on an annual basis. So that should create an annual pattern in how we see these objects tick in space. And
Yeah.
so it's actually pretty easy to test. We can just look and
Okay,
see
so
if,
pulsars, these stars, no, are pulsing
yeah,
at a constant rate or something in
yeah,
the universe?
yes, they presumably are,
Mm.
but the way we see them, it's the rate of pulsing should change depending on the time of year because of the effect I just mentioned. That when we're moving away, we get the
Mm.
light faster. When we're moving towards, we get the light slower. That faster, slower dynamic will change the rate at which the
Mm.
pulsars appear to be pulsing from our perspective.
Okay, and this
If
experiment is not yet
it's
done.
not done yet, but if we look and we don't see any change, then that says my theory is wrong. If we do see a change, very clear that my theory is right.
Mm.
And my theory makes very precise predictions exactly how much of a change we should see.
Mm.
Not just that there should be a change.
So this is your new book, or
Well, it's in the book that I wrote. It's there. The theory's
mm.
there. I didn't put all the math in for exactly how. I mean, I figure it's almost self-explanatory, and I don't need to go into it. Like a lot of the
Mm.
math is so simple, I don't think I need to specify it. But um, like anyone could come up with a way to test it. I think as long as they know conceptually what my theory says, the math just comes easy. Um, but maybe that's just me because I don't like doing math. I just say, oh, it's easy. I'll let someone else take care of it. But it is easy
Mm.
and simple. Um, I don't think that's a big challenge. Uh, you know,
Yeah.
the coming up with ideas is the hard part. Um, so yeah, um, it is kind of strange, but the idea is if you're looking at a pulsar, at one time of year it'll pulse faster, another time it'll pulse slower. And if the main critical factor though is how far away it is and what angle it is in the sky. So if it's aligned with what we call the ecliptic of the Earth,
Mm.
then there's going to be more of an effect. The further north or south it is, the less of an effect you'll see.
Okay,
But
I
also
understand
the
your question. Yeah.
the further away it is, the more of an effect you'll see. The closer it is, if it's within 100 light years, you're not going to see much of an effect. But really far away, 1,000 light years away, you'll see a big effect.
Okay, so but for make this experiment, you need to attract attention from the scientific community, no?
Yeah,
Or something.
I know.
You
I don't
know?
know how to get attention. I've been trying everything, giving away my
Yeah.
book for free, all kinds of stuff. But
Uh,
uh, it's I sent a bunch of emails out and I just don't get any response. So what can you say about that? It'll
yeah.
take time. I think what has to happen
I
is
think
that
Einstein, he um, have had the same situation because
mm,
first time when he came with his theory, nobody listened to him, nobody
mm,
understood him. Everybody said,
mm,
"What is with this garbage? This guy
mm,
is nobody." And then Bohr came. I think this is the real history. I don't know. I just saw a movie. Bohr, from the guy from quantum physics, came and
mm.
said, "This guy is right." And after he said this, everybody listened to him, take his theory in serious, and he became what he became.
Yeah, I think that
But
just proves that as even though we try to be scientific, we're really just social animals and we're very
yeah,
religious by nature.
I
You
think
know.
a lot of scientists are just working in the field for money. They are respecting some classic things which
Mm,
are respected by most of the scientists, and just stuck in this perception, and they don't have the courage to modify it because otherwise they are losing their jobs. Or yeah,
Yeah, a
the
lot of
majority is
it's
think like this.
complicated.
Yeah,
How do various like cults or different ideologies or
yeah,
schools of thought, how do they survive over time? It's complicated, but money's always a big factor,
yeah. It's a
right?
big thought.
If there's no money in it, there's not going to be a lot of interest. And yeah, most of the money goes into making these really big, expensive machines that don't really produce any science.
And you will destroy all the
I would,
movies, sci-fi movies, with time traveling, with this kind of things.
yeah,
Yeah? It's not
I will
possible
just.
anymore.
I'm the big destroyer, you could say. Like that might be the why I get so much silence because it's like,
Yeah.
okay, well, so we wasted our time and
No,
now
we are going
party's
back
over.
to Newton.
Yeah,
And
party's over. That's
Newton,
what I'm
it's
saying.
huh?
My big message is the party's over.
Uh,
Uh,
yeah,
but you know what? People could just ignore me. Like, no, party's not over. We're continuing. Thank you very much.
we like it.
But you know what? It's fine. We don't have to. I mean, I think there's just as much, you know, intellectual activity on the other side. If my theory is correct and we accept it, there's plenty more science to be done. Either way. So it's an end of one chapter and a beginning of a new one.
But
But
anyway,
anyways,
the
speaking
problem
of ending
is
chapters, my battery's getting very low.
okay, yeah,
So I
okay,
just
I
want to wrap
understand.
this up.
Okay,
So
so
you're
maybe we'll talk another time or
okay.
something if new questions
Sure.
will appear. I will try to read your book because I read it just a part of it, not completely.
Mhm.
But I was when I read it, I was totally agree with what I read, the first chapters. But I will try to read it more to complete. Yeah.
Mhm.
But anyway, I was stuck in the videos. This was the
Well,
problem. In the
you've
understanding the videos.
you've you've gone through the hardest chapters are chapter 1 and 2. Those are really hard to get through. After that, it's actually pretty smooth sailing.
Mm. Okay, I'll try.
Anyway,
I'll try to read it all.
it's just I would just say just have fun with it because that's what I was doing when I was writing, just having fun, exploring lots of ideas, and
Mm.
asking lots of questions.
Yeah.
Anyway, all right. Hopefully, we'll talk again soon.
Yes, and I hope your next book will come very soon, and the next podcasts you made with the guy from Nepal. Yeah.
Yeah, they'll be coming. I think it should be at least 6 or 7 more, and then they'll probably come to Canada too at some point, and or we might meet somewhere else. But
Mm.
there'll be more for sure.
Yes, I'm expecting all of them.
And then it'll be Joe Rogan, and then well, no, we'll see. Hopefully,
Yeah. Okay.
okay. Talk to you soon.
Yes. Nice talking to you. Yeah. Goodbye.
Take care.